let's do an example. Name each pair of parallel lines. Let's start off with the congruent ones first. Remember that these are the pairs of congruent angles, and we'll start off with the first one, alternate interior. Remember that with alternate interior, you're looking for a Z shape, and you might see a Z shape here. See that? Angles 3 and 6. And technically speaking, angles 3 and 6 are in fact alternate interior angles. But they aren't necessarily congruent, which is what we're looking for here. Remember that congruent angles come from the parallel lines. So perhaps we should consider getting rid of this line in general, since it's not parallel and yet it's not a transversal because it isn't even cutting through the other two parallel lines. So how about we just fade that for now? By the way, when doing problems like this, it's a good idea to consider redrawing the figure to help suit your needs. Now when I fade that line out, you'll notice that some angles disappear. So that makes this a little bit easier. We can more readily identify the interior. And based on that, we can now more readily identify angles that are in fact congruent. Remember the Z shape? Well, you might see it here, albeit a backward Z. You might also see it here. So with two Z shapes, we get two pairs of alternate interior angles. The first one being angles 3 and 9, and the other one right here with angle 4 and angle 10. So those are the alternate interior angles. What about alternate exterior? Again, this is our original diagram, so hopefully you can see that between two lines, say these two, that's the interior. Therefore, the exterior angles would be, say, angle 1 and angle 8, because, again, alternate sides, that's one side, and then that's the other side of the transversal. However, again, we're looking for angles that are congruent, and that doesn't fit the bill because, again, this middle line is not parallel to this one. And congruent angles are created by parallel lines. So again, let's fade that away. In fact, maybe we should just fade it away permanently. So take this line here. In fact, when you redraw, just simply redraw it without that middle line here. So let's just let it go away. So alternate exterior, again, focusing on the interior there, or exterior, we just mean the outer angles. If one angle you're referring to is angle 1, then another angle would either have to be 11 or 12. Remember, it wouldn't be 2 because that would form linear angles. Remember that linear angles together would form a straight line, and that would mean that we wouldn't even need the other parallel side, so angle 2 is a non-option. So again, either 11 or 12. Remember, we want alternates, so since we have one angle on the top side, we want an angle on the bottom side, which means 12 would go with angle 1. And hopefully you spot another. Yep, that's right, angles 2 and 11, because again, they kind of satisfy the same requirement. One on the outside, and then on the opposite side, or rather the alternate side of the transversal. How about corresponding? Remember, corresponding is a mixture. It is a mixture between interior and exterior, and yet at the same time, we're not talking about alternates, so we mean the same side here. That's the interior. Let's choose an angle inside. How about angle 3? Now, an angle that is corresponding to 3 is going to have to be on the same side of this transversal, so somewhere up top, either angles 1, 3, 10, or 11. And remember, it's not going to be angle 1 because that forms linear angles, and that would not utilize the other side here. So it's either going to be 10 or 11. And remember, it's a mixture of interior and exterior, so if one is interior already, then we focus on one that's not on the inside, but rather on the outside. So that leaves one other possibility, angle 11. Can you spot any others? In fact, there are 3 more pairs. And there they are. Now let's focus on these supplementary angles. These are the 2 that we identified. Let's start with the first one. Remember that same-side interior angles form a C shape, so you can make a letter C like this, and whatever 2 angles that are trapped in there are your same-side interior. Note that both angles are, in fact, inside between the parallel lines. So we're talking angles 3 and 10 here, and hopefully you see a second pair. And again, I'll trace that C pattern there for a visual. What about same side exterior? Well, yes, we mean the same side of the transversal. So let's say we're talking about this side. The exterior, remember, is that side. So the part that overlaps 2 and 12, that would be a pair of same side exterior angles. Do you see another pair? I'll give you a hint. Which ones overlap here? If you guessed 1 and 11, you guessed correctly. Then again, I'm sure that you weren't really guessing. Hopefully by now you've figured out the pattern to this and how the words give us a hint on what to look for. Okay, here's an example that involves some algebra. We have 2 angles, one identified as 55 degrees and the other as 6x plus 1 degrees. Now let's kind of draw in here a couple parts here that are missing from something that we would normally recognize. Because these 2 lines are parallel, let's kind of draw them all the way through. Since this is the transversal, we have that drawn all the way through. How's that? Okay, now based on that we can more clearly see exterior angles and interior angles. Notice that both angles are in the interior, and also notice that both angles are on alternate sides of this transversal running across. So with reference to this transversal, you have one angle on top and you have one angle on the bottom. Recall that the same side angles in the interior or in the exterior are the ones that are supplementary. So these 2 particular angles are congruent to one another. For example, you can see that this angle measure here is the same as this one here, and these 2 are in fact vertical angles. So definitely are congruent. So the way we set this up is as such. Take your 6x plus 1 and then set it equal to the other angle, 55 degrees. Once you have it like this, the rest is just simple algebra. Minus 1 from both sides, and then divide 6 from both sides to get your final answer. And that's all there is to it. If you can remember the relationships that these angles have with one another and be able to identify them, then you'll be more easily able to set up the problems and then solve them. Here's another one, only in the context of a proof. You have 2 sides here that are parallel, and you're given one angle being 4x degrees and the other being 3x plus 4 degrees. So prove that this angle measures 96 degrees. Since it says prove here, we'll do this in the context of a proof, and you can do the proof in several different ways. In this case, I'll choose to use a table and do your basic statement and reason setup. Now, remember that in looking at these angles here, you should recognize that they are in the interior. So we're talking about interior angles. And notice that the interior angles are on the same side of this transversal. And if you're not seeing it yet, maybe that better illustrates it. That's your transversal. This is the same side. Also note that we got a C shape here. So hopefully you see now that they are in fact alternate interior angles. Strike that, same side interior angles. So that's the one we're looking for. And same side interior angles, angles between the parallel lines that are 180 degrees when you add them up. So now we have an expectation of how to approach this problem. Now in a proof, we kind of have an idea of already how to start this. We start with what's given. So we know that this is the beginning. We also know the ending too, that angle A is going to be 96 degrees. So let's worry about the middle. Now since we just established that these two angles are supplementary, that means you're going to have to add them up. So let's take angle A and add it to angle T. And since they equal 180, remember the reason that we know this is true? Because those are same side interior angles, and same side interior angles are supplementary. Okay, now that we've established that these two angles add up to 180, let's actually put in what their values are. That is that angle A is 4x, and that angle T is 3x plus 4. Again, angle A is 4x, that's stated right here. So we're writing that in place of it, which means we are substituting. Okay, now once you get this far, you're just doing some basic algebra here. Distributive property on this part, 3 times x plus 4, you're multiplying 3 to both of those terms here. And I think you can guess what happens next. We have like terms. Subtract 12 from both sides. Then divide by 7 to get your answer for x. However, please keep in mind, it's usually when you do a problem like this, you think, oh, okay, I've solved for x. I'm done. But don't forget what you're supposed to do here. You're supposed to prove that angle A is 96 degrees. Because of that, you need to state something about angle A and what it equals. So we're going to do that here. And remember that before we pointed out that angle A is 4x, so I'm just simply rewriting it down here, only instead of the x, we're putting in what we know to be x. And that would be substitution. And there you have it. That's how you do it in the context of a proof. Now, just keep in mind that the algebraic part, essentially this portion here, should be pretty automatic to you. And as far as the reasons are concerned, pointing out those reasons are really not the most important to me. However, being able to cite this and this and this are in fact of greater importance. So make sure that you're able to remember those properties. That's it for this one. I'll see you next time.